Alrighties, hello everyone, welcome to your pre-lesson video today on right triangles. So we have quite some things to cover, so let's get right into it. So the first thing that we're going to cover today is on the Pythagorean Theorem, right? So essentially what the Pythagorean Theorem states is that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse, right? So as you can see here, the legs of our right triangle is going to be A and B, and our hypotenuse, which is, remember, is the longest side of the triangle, and if it's for a right triangle, it will be directly across the 90 degrees. All right, that'll be the hypotenuse. Now, essentially, what that statement translates to as an equation is a squared plus b squared equals c squared, right? Because a and b are the legs of our right triangle and c is our hypotenuse. So we are squaring them to find one of the legs that we're missing. And right now we're going to see how that is applied. So solve these triangles. So the first thing I'm going to do is I'm going to write down what is my a and b. So here I'm going to say that my a is 5 and my b is 12. All right. Now they can be interchanged. My b could also be 5 and my a also could be 12. Doesn't really matter as long as a and b are the legs of the triangle. All right. And we are trying to find c because we don't know what it is. So I'm just going to write the equation plus b squared equals c squared. So now I'm going to plug it in for the values that I know. So 5 squared plus 12 squared equals c squared. From there, 25 plus 144 equals c squared. All right. Now I know that c squared would equal to 169 and but we're not done yet because we want c by itself, so we need to isolate it. So to get rid of the square, we are going to square root both sides of the equation, right? So then we're going to get c equals square root 169. All right, and if 169 wasn't a perfect square, then we would just leave it as it is. But it is a perfect square, so we would actually get c as 13, and that will be the answer. All right. So now let's look at another question. So my A is 9, my C is 15, and I want to find out what my B is, right? So if I were to put it in an equation, it'll be 9 squared plus B squared equals 15 squared, which will be the same as 81 plus B squared equals to 225. Now I want to isolate both sides of the equation. I want to isolate b squared, right? So I'm going to subtract 81 from both sides of the equation to give me b squared equals 144. All right, now I'm going to square root both sides of the equation to finally give me b equals 12. And that is how you would use the Pythagorean theorem to find the missing length of a triangle. So whether it's the hypotenuse or the leg, you would use this, right? Especially if it's a right triangle. Now we could also use the Pythagorean theorem to test if it is a triangle that has a right angle. And here is how. So we are given this triangle, right? Where its lengths are 10, 24, and 26. Now, I know my legs are going to be 10 and 24 because, again, my hypotenuse is going to be the longest side of the triangle. So that means my A is, I'm just going to say it's 10, my B is 24, and my C is 26. And now I'm going to see if this equation is true, right? So it means I'm going to have 10 squared plus 24 squared equals 26 squared. All right. So again, 100 plus 576 equals to 676. If I add the left side together, I will get 676 equals to 676. And obviously that is true, right? So that means that, yes, it has a right angle. All right, there we go. Now let's look at this next example, right? So does an 8, 15, and 16 triangle have a right angle? So again, I'm just going to denote that my A is 8, my B is 15, and my C is 16. If I were to put that in the equation, it'll be 8 squared plus 15 squared equals 16 squared. So it becomes 64 plus 225 equals to 256. Now, if I were to add the left side up, I'll get 289 equals to 256. But this is not true, so we're going to put that there, right? So 289 does not equal to 256. Therefore, does this triangle have a right angle? And the answer is no. All right. So if you have any questions about how to use Pythagorean Theorem in the test, if it has a right angle or not, or how to find a missing length of a triangle, send me a message or bring it to your deep dive lesson. All right. Now for some special angles, some special right triangles, right? So we have the 30, 60, 90, and 45, 44, 90 degree triangles. And so let's look at the 30, 60, 90 first. So the 30, 60, 90 triangle has side length ratio of 1 to square root 3 to 2. All right. So as you can see, opposite of 30 degrees is A, opposite of 90 degrees is A to the is A square root 3, and opposite of 90 degrees is 2A. Right. Now here's a trick to find out if you ever have these questions, how to solve it. Easiest thing is obviously to always find A, because you just need to plug in A here to get the other side length, right? So let's say you are given the hypotenuse, and if you want to find A, all you need to do is divide by 2. All right. And now if you're given the longer leg, all you need to do in order to find A is to divide by square root 3. All right. So that's the trick to know, and we'll actually see in a second how we're going to apply this. All right. Now on to the next type of triangle is a 45, 45, 6. Sorry, I meant it right. 45, 45, 90. Here we go. 45, 45, 45, 90 triangle. It has side length ratios of 1 to 1 to square root 2. So as you can see, the reason that they're the same is because, you know, our angle is the same. So essentially it's an isosceles triangle, right? So here's A, and then our hypotenuse would be A square root 2. All right. Now, in order to find what A is, given the hypotenuse, all we would need to do here is divide by square root 2. All right. Now, on the flip side, if we want to find out our hypotenuse given A, all we would need to do is the opposite. So we're just going to multiply A by square root 2. All right. So now let's see how this is all applied so that you can use it in questions. So let's see. Find the other sides of the triangle shown below. So if I were to label the sides, I know that TI is A square root 3 because it is opposite of the 60 degrees. My 14 is my 2A because that's the hypotenuse. And IR is going to be A because that is opposite of 30 degrees. All right, so now if I were to label everything here, TR is 14 inches, IR is A, and TI is A square root 3. Alright, so the easiest thing right now for me to do is to find out what A is. And I know that my hypotenuse is 14, which is also equivalent to 2A. Alright, so all I need to do in order to find IR is to divide my hypotenuse by 2. So 14 divided by 2, which would give me 7 inches. Alright, so it means IR is 7 inches. Now straight away from this, because I just found out what A is, right, because A is 7, I now know that TI is going to be 7 square root 3 inches because of this property of 30, 60, 90 degree triangle. Alright, so this is going to be 7 square root 3 inches. And that's how you would use it to find the side lengths, missing side lengths of a triangle with 30, 60, and 90 degrees. All right. Now on to the next one. How long is each side of the square? So we notice this is an isosceles triangle and one of our angles is 90. That means these two are going to be congruent, right? So in this case, they're going to be 45 and 45. Okay. So this is going to be 45 degrees. Because of this, I know that this is going to be A, this is also going to be A, and my hypotenuse, which is given as 16 centimeters, is going to be A square root 2. Alright, now I want to find out what A is. So if I were to write this into as an equation, it'll be A square root 2 equals 16. Isolate A by dividing both sides by square root 2 to give me 16 over square root 2. Alright, so that means each of my sides are going to be 16 over square root 2. Alright. Each side is 16 over square root 2 centimeters long. Now sometimes maybe there's a possibility that the question doesn't give you as this. It's because we can actually rationalize the denominator, and here's what we're going to do to rationalize it for like a short recap, right? So we want to rationalize the denominator because we don't want a square root for the denominator. So to get rid of the square root, we're just going to multiply the top and the bottom of the fraction with square root 2. Okay, I should just rewrite that. Alright, now this is going to give me 16 square root 2 over square root 4, which I can now simplify as 16 square root 2 over 2. I can now simplify this because these two numbers are divisible, right? So that means I can finally get 8 square root 2. That means each side is also 8 square root 2 centimeters long. So we can write this either way, so it really depends on what the answer options give you. Alright, and this is it for your pre-lesson video on right triangles. If you have any questions, as usual, send me an email or bring it to your deep dive lesson. Alright, thanks for tuning in. Have a good rest of your day.